Okay, so let's go through this example on a definite integral, doing the integration by substitution. Okay, so if we let u equal the x cubed plus 4, then if you take the derivative, this would be 3x squared with respect to x. Derivative of the 4 would be 0, right? And you need to be able to substitute in for this, okay? So that means you need to get rid of the 3, so multiply by a third. So 1/3 du equals the x squared with respect to x, okay? And I'm actually working this the first method, okay? But you can do it the other way too. I can do it both ways. So on this, if I rewrite this in terms of u, this would be u squared in the bottom and the 1/3 du up in the top. Okay, and I'm not putting, there aren't any values that go here because I didn't calculate any new values for in terms of u. So the 1/3 goes out front. Okay, and then I have the integral of u squared in the denominator with respect to u. So if I move that up, okay, I'm going to leave the 1/3 out front. If I move that up, that's going to be u to the -2 power with respect to u. Okay, so far? Okay, then leave the 1/3. Now you do the antiderivative. Add 1 to that exponent. Divide by the new exponent. So if I add 1 to that, it's going to make it u to the -1. Divide by the new exponent. Divide by -1. Okay, and then if I simplify, 1/3 times -1 is just going to be a -1/3 u to the -1 power. And then I still, now if I started with an x, I've got an end with an x, so I've got to substitute this back in. And what's that -1 do to it? Yeah, it moves it down to the denominator. So it's like -1/3. I'll work it in stages. So this would be x cubed plus 4 to the -1 power. And then they're going to put the little bracket here and say, go from, now because I'm back in terms of x, I'm going to go from -1 to 2. Okay. So leave the -1/3 out front. Okay. I could leave that -1/3 in front of both fractions, or I can leave it out front in front of the whole thing. So, and I don't care which way you do it. If you substitute in the this -1 is going to move that down to the denominator, so it's 1 over x cubed plus 4. Okay, and then it's from -1 to 2. Okay, so equals. Leave the -1/3 out front. Now put 2 in, so it'd be 1 over 2 cubed plus 4. Okay, and then minus, and then 1 over -1 cubed plus 4. Okay, so far, check my arithmetic. It'd be -1/3, and then that would be 2 cubed would be 8, so that'd be 1/12. Okay, minus, and that would be what, 1/3, right? Okay, and then leave the -1/3 out front. If you get a common denominator, it would be 12. Multiply this by 4, multiply this by 4. Okay, so you get a -1/3, and this would be a -3/12. You can reduce a negative times a negative would be a positive. The 3's would divide out. And you should end up with a final answer of 1/12. Okay? Okay, anybody need to see the other method? The other one? Okay, let me do the other one. Okay, same problem. This would be method 2. Okay, so it's the definite integral of x squared with respect to x divided by x to the 3rd plus 4, that quantity squared, from -1 to 2. I would still let u equal the same, let u equal the x cubed plus 4, take the derivative, This would be 3x squared with respect to x. You still want to substitute in for the x squared dx, so multiply by a third on both sides. So that's basically still the same. The only part that's different is you rewrite this as a function. So u of x equals x to the third plus 3. So sub in 2, you sub in the top one. So 2 cubed plus 4, that'd be the 8 plus 4 would be 12. And then sub in the negative 1. So negative 1 cubed plus 4 would be 3. Okay? So now when you sub in the definite integral, we're going to have the 1/3 du up on top. Down on the bottom, we're still going to have the u squared. Now, the only difference now, you can put in these new values. And the new values are 12 and 3. Okay, so far? Okay, take the 1/3 out front, so it's very similar. I can go ahead and move that u squared up on top, so it's going to be u to the negative 2 du from 3 to 12. I can leave that 1/3 out in front of all of it. Add 1 to that exponent, so it's u to the negative 1 over negative 1, and then evaluate that from 3 to 12. So leave the 1/3 out front, and then if you put in 12, it'd be 12 to the negative 1 power over negative 1 minus, then put in 3, so it'd be 3 to the negative 1 power over negative 1. So leave the 1/3 out front, and this negative exponent is just going to move that down, so it's like a negative 1/12 minus, it will move this 3 down, so it'd still be a negative 1/3. Okay. So we have a 1/3 out front. Check my arithmetic. Am I okay so far? And that'd be 12, that would be 4. This one was negative, and this one would be positive because minus a negative. So that'd be 3/12. So you'd have 1/3 of 3/12. Those would reduce. Final answer would be 1/12. Okay, so it doesn't matter whether you go method 1, method 2, you should still get the same answer. Okay? Okay?